Friday, when you do come to me, and I'm going to have a guest teacher here, you will be taking the Chapter 8 Mastery. If you get done with the Chapter 8 Mastery, you can start on the Chapter 10 if you feel like it. You don't have to. There's no pressure. Chapter 8 is your top priority. If you don't get done with Chapter 8, totally fine. We can finish on Monday. No worries. That is just what you should be working on until I return. Straveler?
Can I run to my locker to get a pencil?
No. You can borrow one of mine.
Thank you.
How about with you?
Hey, if you're going to give it back to me at the end of class.
He has a pencil in his hand. Doesn't have an eraser though. Oh my god.
Here, borrow an eraser.
Make sure I get back.
I know, those are the best erasers. Brian, did you say thank you?
Yeah.
Okay.
Thank you.
I said thank you.
Brian.
I didn't hear it.
I
No
did.
one or-
Wait, where does crystal come from?
You know what? People remember a lot more easily than they remember good things, bad things.
I said thank you.
People will
An elephant
much...
never forgets.
Yeah.
What?
An elephant never always remembers.
Never always remembers?
No.
Okay, so we are today just wrapping up our exponent work with some problem solving. So we already reviewed this key concept. So this should be a fairly quick lesson, and then we should be able to put some time towards practice work. And tomorrow we will finish wrapping up Chapter 8. Any last questions that you have, and we might even do like a test prep sort of thing where we solve some problems like what will be on the test. So if we go to simplify number A there, first off, how would we read it? And then, and obviously some of this is pretty basic, how would we read it and what does it become? Scarlett? A would be read. And that turns into what times itself would equal 125. So think about the fact that it ends in a 5, so that starts to limit your factors that could go into it. Give it to me. It's okay. Because 5 times 5 is 25, times 5 is 125. In B, Carmen, how's that read and what's it turn into? Yeah, the 4th root. So once we get beyond cube root, there are no special names. It's 4th root, 5th root, 6th root, whatever. So what's it turn into, Carmen? So try it out. 2 times 2 is 4, times 2 is 8, times 2, 16. Calvin, got it?
3.
And that is read the...
Cube root 27.
Thank you. Like I said, this should be a very quick lesson. Actually, and when we get to this mastery, it should be a pretty straightforward mastery too. I think we're decent with our exponent work. So now this gets a little bit more tricky. So, in A here, Emma, explain what is happening. Can you talk through that whole value? I don't want to say it because I feel like I'll give it away. When we go to apply that rational power, that gives us a power and a root. So how do I do that? The what? The Oh, you were way down at problem 3. Oh, we're here in problem 2.
Yeah.
So, now be careful. What is that exponent acting on? Just the A. Ah. So 12 times cube root of A squared.
Wait, I have a question.
Yeah.
I mean, but I think you said the bottom one stayed and the top one.
Yeah.
Yeah, it doesn't.
No, the bottom one.
The denominator is the root value.
Right.
Oh, okay.
The numerator is the power value.
Cool.
Then in B is now different because we have the parentheses around the 64A. Straveler?
I think it would be 5th root of 64A to the 4th power.
So David thinks it's fifth root of 64a to the fourth? Just because I reacted differently than normal. Michelle? This 4 is going to go into both values in here. So this is also 64 to the fourth. Now wait. So I've got, if I kind of break this up and expand it, I've got the fifth root of 64 to the fourth times the fifth root of a to the fourth. Now, yeah, 64 to the fourth would be 64 times itself.
That's a big number.
Yeah.
No kidding.
So, avoid that big number. What if we had, let's just say, 2 squared to the cube root? Or 2 is a bad example. What if we do 4? Well, what would be 4 squared? So what would be the cube root of 16? Something weird, right? But does that work the same way? Like, is there a way that I can make this easier? Do I have to evaluate 64 to the fourth and then take the fifth root of it, which may or may not work out nicely? Is there any easier way to deal with this, Traveler?
Couldn't you, like, root the 64, make it 8 to the 5th power? I don't know.
So you're saying make it 8? So if I rewrite this as fifth root of 8 squared to the fourth, right? So that would actually be the fifth root of 8 to the 8th. I'm trying to get you, like, so what do we do with that? Is there an well, so if we use the big values, right? 64 to the fourth, then we take the fifth root. Do you guys, by the way, know how to do the any root? I'm just making sure that I know a few of you do. On these calculators, or on any calculator, how do we do the any roots? Like where you type in root, Ethan?
Is it called the caret sign? It's like the up arrow.
Okay. What about that?
Okay, you would put in a number. So if you want to get the root of if you want to do 8 to the 5th, you would hit 8, caret.
Now that's any power.
Oh, I know the root.
We need to root with a value bigger than like square root or cube root, right?
It would be the second caret.
The second of the caret function. So grab, and if you don't have one of these, please grab one just to make sure you're familiar with it. If you hit second and then that button, it just pops up with your root. So if I want fifth root, I type the 5 in first. So then I could, inside the root, open up a parentheses and do my 64 to the fourth. But did anyone get a syntax error? Yeah, anyone get a syntax error? So here's the thing to watch out for, because I had a question about this from a different student. If it ends the parentheses as part of the power, because when you use the caret to type in this fourth power, if your parentheses stays up here, you're going to get a syntax error. Because you have an open parentheses, well, depending on how you type it in. So be careful that when you go to close your parentheses, you have to bump to the right, like hit the right arrow, and make it a big parentheses. Colin?
Does it only put parentheses on certain calculators?
What do you mean it?
Well, like, are those parentheses put in by us? Saying,
I did. So if I just type in fifth root.
yeah.
No, mine would.
Oh, you're talking about whether your any root goes ahead and opens the parentheses?
Oh, the square root
I
does,
don't
but the
even.
any root doesn't.
Yeah, here's my TI's other one. The any root value, so say fifth root, when you hit it, it doesn't have an open parentheses. So I could just type in a number and then hit enter, but if I need to type in an expression like 64 to the fourth, I want to open a parentheses to like contain that expression. Yeah.
I have something to point out.
Okay.
Dave, you want to say it? 8 to the 8th is the same thing as 64 to the 4th.
I know.
Yeah.
That was what we were saying.
Oh, you
Okay,
didn't tell me that.
We were just trying to find a different way to work with this. But what I'm trying to figure out is there any easier way instead of having to take the 4th power and then the 5th root? Like, what if we just did... Ethan? So, how many of us have graphing calculators? The 83s. Anybody else use the 83 at home or anytime? So, in here, to get there, you go math, and then down to your root. So, the 5th option down to math screen. But it needs to know what the root is, so it grabbed your previous answer since you didn't tell it anything. So, if I want to do 5th root, take 5, hit math, go down to your root, grab it, and then you can type in whatever you want. And that is going to 5th root it. Even though that 5 is still kind of big out there, it's using that as your root. So, where I was trying to go with this is avoiding a mistake. And I never really anticipated this till a student did it, so I'm not thinking any of you would have done this, but I had a previous student who said, well, if I have 5 roots and 4 powers, I have 1 more root than I have power, so really this is just the square root of 64. No. So, that's why I was trying to tease out, like, is there anything else we could do with it? I don't think any of you would do that, but just to say it, you can't deal with roots and powers like that. You have to deal inside, outside, because if we follow order of operations, really that root symbol is a grouping symbol. It falls under the parentheses when we work down PEMDAS. I really wish PEMDAS, instead of parentheses, it just said grouping, because any grouping symbol has to happen first. Okay, so we do our 4th power, then we work out and do our 5th root. And this would turn into approximately, what did we get, 27.9 if I round up. And then 5th root a to the 4th, if I wanted it in decimal form. But since it just says radical form, we could have left it right out here if we felt. Or we could put those together under 1 root if we want. So it'd be cleaner. Sorry, I can't leave it just saying it. It'd be cleaner if we did this. And then it would be even better if we did our 64 to the 4th, but 64 to the 4th is such a big number, I'm not going to worry about that right now. But if you wanted to clean it up, go ahead and write that as what it is. What is 64 to the 4th?
16,777,216.
Yeah, I'm just going to leave it like that. Questions? Yeah, that's a bit. Well, think about it. 64 times 64, then times 64, then 1 more times 64,
My
it gets
question
huge.
is how all the 7s got there. It's like you have such an even number as 64, and then you get 3 7s.
It's even all the way to that point.
Yeah, like 16777. Interesting. All right, so in radical form here, working on through. Ethan, what does a to the 5/6 turn into in radical form?
6th root of a to the 5th.
Yeah, the 6th root of a to the 5th. What? I know that I feel like the Math 2 text is like reverse of how the other texts are written, because the guidance in the other text often push to like, did you really get it? But I wonder, because it was high school content, if it's like, all right, it's really hard when we do it together. Try it on your own. We'll make it a little bit easier. So I don't know. But we're switching text this year anyways. We're getting a new publisher.
Who?
We don't know yet. We haven't chosen it. I'm not on that panel.
You just don't like this one?
So we bought the Pearson text pretty soon after the Common Core switch. And not that it's a bad text, but it like they just made it really quickly. Like when they released the Common Core standards and they're like, hey, everyone's going to change what they're teaching, it was a mad dash to who could make a text that people would want to buy. And Pearson's is good, but it's not as good as things that are out there now that have had more time to make a really good text. Problem 3 here. We want to take our radical into our exponential. So remember, the power under the radical is the numerator. The root value is the denominator. So Caleb,
Yes, sir.
that's fine. I'm using cards to make sure that I talk with everybody. Caleb, what does A turn into?
A turns into B, and then think it right, and it's B. It's either, I think, 5, no, it's 3 over 5. Right?
It's B to the 3/5. All right, so
I don't
take
know why
a
I
second,
did that.
solve B and solve the got it. Try to get those into exponential form.
So all we do when we have a power and a root is we make it rational. That's going to be numerator. That's going to be so the only difference would be is when we look at like a number inside of here, we have to ask ourselves, can we use a cube root of 27? So I'm going to expand this out a little bit, but then I'm going to expand it just a little bit. How we doing?
Simplify anything that you can. So, all of these values that we've been working with, and I think I've made my peace with saying a string of multiplication where like I can put it in any order I want. So for B, the first thing we really want to do, whether you mentally do it or physically do it, is think about this as the cube root of 27 and the cube root of d to the 5th. Because the 27 and the d to the 5th aren't really connected together except they're multiplied, but I can break that up and they're still multiplied. Strickland?
I'm going to be answered, but
I thought you had a question. So, Lynn, can we take the cube root of 27? So we're thinking what times itself times itself. I think there is one. So if I have a double digit number, remember that like my powers get really, really big really, really fast. So just start thinking through a few numbers. 1, obviously we can skip it. 2 times 2 times 2, well that'd be 8. That doesn't work. 3 times 3 times 3. 3 times 3 is 9. Yeah, so this cube root of 27 really is 3. Then what does this part of your expression become? It'll be d to the... Yeah, kind of. We set up a division. So this is going to be your numerator. The power is your numerator. The root is your denominator. So it'll become d to the 5/3.
The way I always remember which one's the numerator and which is the denominator is if you make, in a fraction, if you make the denominator larger, the fraction gets smaller. And if you make the root larger, then...
Yeah, the value gets smaller.
Yeah.
Yeah, I
and
like
then
that.
reverse for the numerator.
Max, what about the got it for 3?
S to the 2/3.
S
I thought it was an 8.
to the 2/3. Well, if it was 8, what'd you get? It is an S, but if it was an 8,
I would have gotten, think about this quickly, 4.
it would be 4. Because this would really turn into the cube root of 64, and that is 4.
Oh, that is an 8? It's questionable. We just
It's
went over this.
supposed to be an S. But if it was an 8, this would turn into a 4. If it's an S, it's S to the 2/3. Okay? So I don't care which way you evaluate it as long as you understand how to evaluate it.
And you explain yourself.
Yeah.
You say it's an S and then solve it like an 8.
I
Then
hate this was supposed to be here, and that's why the spacing is weird, and yeah.
I don't like it.
I'm sorry. I don't like it either. I'm very upset. Alright, so real application. The metabolic rate of living organisms based on body mass. We can use Kleber's law, which this is actually a real thing. So our formula is that R for rate is 73.3 times the 4th root of m cubed, and is calories per day to body mass. So this is really... Question?
What? No, I'm good.
This is really like giving you a rate that is like, well, rate or ratio, depending, but it's a comparison of how many calories you should eat per your body mass.
Oh, I thought it was like saying if you had so much mass, this was your metabolism rate. I was saying if that was true.
Well, this is where that came from. So, if this is where like the average person needs a 2,000 calorie diet, so that's not really true for many people. Like I don't know why we still use that because everybody's body type is very different. But using Kleber's law, like using the health, nutrition information, whatever, they've determined this formula will give you, if you have a body mass of whatever, it'll tell you how many calories you should eat.
So wait, if that is like if that thing grows with you, how does it know any gain you weight? Because if you consume more, are you automatically burning less? I'm sorry, not consume.
No.
Consume more, you're burning more.
So this is advising how much you should eat based off your body mass. It's not like a hard, fast rule. It's not actually going to determine anything. It can't stop you from eating, but it's going to like suggest what you would consume.
Wouldn't there be like a bunch of other factors that goes into that?
They've done the research to that point that like in general, this will help you. Yeah.
So it's like not like that perfect thing. It's just
I had a situation that made me think of you last night. Let me at the end of the lesson remind me. I gotta tell you.
Your dog wanted candy?
No, it's 2 more days. So if the mass is 18, all right, bring it back. If the mass is 18, let's plug in. So R would equal 73.3 4th root of 18 cubed. I don't really know why I did those parentheses. I think I opened my parenthesis and just decided to keep going with it. So 18 cubed would be, Caleb, I see you punching back there.
8.73885.
Yeah,
Just cubed?
yeah, don't do the 4th root yet.
I also did square root.
what?
Not square root.
5,832.
I second that.
I got that too, but then I also did the 4th root thing.
So now, because we're going to leave this in our calculator, now do the 4th root of that, then multiply it by 73.3.
I got it. It's 640 point. If going around to the nearest 10, 6. If going around to the hundredth, 5, 6.
So that would be calories per day. Now, 18 kilograms. I don't know the conversion kilograms to pounds.
That's not a lot. I'm pretty sure.
Yeah, I forget how many kilograms are in a pound. Because I wonder, what if we plug in our information?
Isn't it like 2 point something pounds in a kilogram?
If you're
I want to say it's 2.2. Nah, there. Okay.
Oh, kilogram in pounds. I'm gonna put.
No, let's make this kilogram 1. Yeah, 2.2 pounds in a kilogram. So, if you take your weight and divide it by 2.2, that's your body mass. So take your weight, just to try this, take your weight, divide it by about 2.2. Huh? Yeah, that'll be your kilogram weight. So your weight divided by 2.2.
Dang, that's a legit Now what?
So now, hold up. Now take that value. Hey guys, are we with me? Or like this is interesting because it actually relates to your like health and wellness. Okay. So take your mass, plug it in for your in your formula. Sorry. So cube your mass.
Excuse the interruption. Could I have Abby Needleman to the office? Abby?
Then fourth root that, which by the way, in case you forget how to get to the any root button, or if your calculator doesn't have it, what's another way that I could take something to the fourth root? Well, but you can't, like, because then that would change, right? Like that can't, you can't divide by something that you don't know what it is yet. So if I want the fourth root of x, what's another way I could type that in my calculator? Yeah, use fractional powers. So if I take this value, because it's kind of easier in my calculator to just start like typing more numbers, I can just hit my power button, my caret, and parenthesis, do 1/4 as the power. That'll give me the fourth root of that value, then multiply it by 73.3 by my body mass. And this is funny, this came out that close. I should be eating 1,994 calories a day. So, 2,000. Now, I'm not standard. Well, depending on what group you would look at. But a lot of Americans do not like fall into that easy category. And a lot of Americans eat way too many calories. By like thousands a day. So, now the other thing though, is you guys should bump yours up because you're growing. You're going through puberty, all that stuff. You need the extra calories. So really, you don't need to worry about your calorie intake until you're like 16, 17, 18. Then you got to kind of watch what you eat.
Do you watch what you eat? Mr. Hudson, do you watch what you eat?
Me?
Yeah.
I watch it as it goes in my mouth. No, but I do. I mean, my wife's a pescatarian, so she only eats fish. So we eat pretty healthy. Most of our meals are. Well, fish is the only meat that she will eat. I said that you're wrong. Fish is the only meat that she will eat. So, a 75 kilogram person, we do the same process again.
That's a fact. They call fish.
I was about to say, bro. According to, well, I don't know. I probably rounded up a bit on my weight, but according to this, I'm 81 kilograms. So thanks, dude.
I didn't say fat, I said tall.
I have said fat at first.
Yeah.
I was still thinking of that.
And Straveler, how many calories would this person need?
1868.1.
So like I thought, fairly quick lesson. Any questions remaining about working with exponents? Tomorrow we will finish wrapping up chapter 8. And maybe if you guys decide, we would just start the master tomorrow. If you guys feel ready.
I don't think so.
I need to
Battery's dead.
What was the story that you thought of that?
So last night, I was finishing, and I wiped my iPhone this morning, so I don't think I have any pictures. I might, actually, no.
Why do you wipe your iPhone?
I'm trying to fix my battery issues before I go to California. Thing can't hold a charge.